Since it's y, I'm going to put it in the y spot. And then we're going to solve for the other variable, which is x. So it's x plus y, which we're now replacing with 2, equal to 6. All right, so see how we just plugged it in? Yes. Yes. All right, and then we're solving for x. So how can I get the x by itself? Good, we're going to subtract 2 on each side. So that cancels it out over here, and x equals what? 4. Right, so I know x equals 4. I can make like a little note to the side, because remember your answer should be written as a coordinate. So my x value in that coordinate is 4. I just need to find the y value. But do I already know what the y value is in this one? What is it? 2. It told me in the equation, right? So this time I didn't actually have to go through the method of solving. But normally you would plug in this x value into the equation and solve for the y. All right, the y is already solved. That makes sense so far. All right, so we know that our answer is 4, 2, because it should be written as a coordinate. Did that by substituting it into the other equation. Now compare it to what we did yesterday for graphing. Both of those I can graph. Just what form do they need to be in order for me to graph them? Good. Is y equals 2 in slope-intercept form? It is actually. It just doesn't have a slope. All right. The slope is 0. So what's my y-intercept? 2. And since it doesn't have a slope, the slope is 0. It's just a horizontal line. I don't know if you remember back then, but when it's y equals a number, it's a horizontal line. All right, and then the other one was x plus y equals 6. Is that in slope-intercept form? Y equals mx plus b form, is it? How can I make it that form? Good, do that on each side. And y equals in slope-intercept form. Good, and now graph this one. So what's my y-intercept of this one? 6. And my slope is good, -1 over 1. So since it's negative, we go down 1 to the right 1. Down 1 to the right 1. And we keep going until the lines intersect, which I can see where they intersect now. Let me just draw my line. All right, and where do they intersect at? At 4, 2. Does that match what we got when we did it by substitution? Yes, so this kind of just proves that we did it right, right? So there's multiple ways of finding the answer. You might think one is easier than the other, like who thinks graphing is easier? Substitution is easier, at least so far, right? It's up to you, there's no wrong answers. So whatever is easier is perfectly fine. You might have noticed on the practice yesterday, like, what is it, 4 through 6, you had to approximate them because sometimes the graph doesn't intersect at like a nice spot, right? So you might have noticed that. That's like the pitfalls of graphing sometimes. So maybe substitution might be better for some of them. All right, so another example. A little bit meatier this time. There's more stuff in there. So we need to get one of those equations where the variable is solved for. So where one of the variables is alone on one side of the equal sign. Is that already present? yeah, I have a y equals 4x. That y is by itself. So I don't have to rearrange it or anything. I can just use that one. So I'm going to take what it equals, which is 4x, and plug it into the other equation. Where will I plug it into? Into y, because that's what y equals. So I had 5x plus 2y equals 39. And then when we replace the y, so now it's 2 times 4x equals 39. All right, so again, just plugging it in. All right, now solve for x. We're able to do that now because x is the only variable in this equation. There's no longer two different variables where before we couldn't solve for x. So now just solve for x. So what's 2 times 4x? Thank you, 8x. Plus 5x equals 39. Combine like terms. What's 5x plus 8x? 13x equals 39. How do you get the x by itself? Oh, I don't know why it's 2. Divide by 13. And do that on each side. And x equals. All right, are we finished? Did we find our entire answer? Not exactly yet, or maybe you did it in your head. We know that x is 3, but our answer should be written as what? A coordinate. So I need that y value. So here's what you do now. You take what x equals, which is 3, and plug it back into one of the original equations. I think they usually say to put it in the other one. Put it in whichever one looks easier. So I'm going to plug it into the top one, because that one's shorter. All right, so I have y equals 4 times x, but now we're replacing x with 3. So y equals 4 times 3, which is 12. Now we have the entire answer. This coordinate is my entire answer. Questions there? And really get in the habit of writing it as a coordinate. I have seen people just like circle x equals 3 and y equals 12, but write it as a coordinate. Because I have seen on a test, a good way to trick you would be to have coordinates listed, and then they flip it. They put like 12, 3. All right, so just practice it. Questions there? All right, so when it's like this, where the equations are already pretty simple, I would probably use substitution. For this equation on example 3, I probably wouldn't use substitution. But we haven't learned the method yet that I would use, so we'll practice it with substitution and you can decide which one you like best when you do it. All right, but we're going to go through the steps. We need to solve one of the equations for one of its variables. So pick an equation. It doesn't matter which one, the top one or the bottom. All right, and we're going to solve for one of its variables. So we can solve for x or for y. Which one do you think might be easier? Good. If I solve for y, it's just one step. So how do I get rid of the 3x? Good. And we get y equals negative 3x minus 3. So we completed step 1. We solved one of the equations for one of its variables. And now the y is by itself. Questions there? All right, step 2, we're going to substitute the expression. So if you don't remember what expressions are, they're like not equations, they're mathematical sentences, but without the equal sign. So we're substituting the expression from step 1 into the other equation and solving for the other variable. So the equation that we didn't touch, this one, is where we are plugging in that expression. All right, so I have negative 2x plus y, but instead of writing y, I'm going to plug in what we wrote for what y equals. And I'm going to put it in parentheses because sometimes it does make a difference. Usually you have to distribute. All right, so everyone see how I just plugged it in for y? Anyone confused where the numbers are coming from? All right, so plug it in for y. Now solve for x. Normally there's a number out here. What number is out here if it's not written? Does that really change anything when I distribute it? No, so the parentheses basically just go away. So I have negative 2x minus 3x minus 3 equal to 7. Are there any like terms that I can combine? And when I combine them, I get good, negative 5x minus 3 equals 7. How do you get x by itself? Good, so add 3 to each side. On the left side, I have negative 5x. On the right, what do I have? 10. And then get x by itself. Opposite of multiplying negative 5 is good. Do that on each side. Miss Medina. I have Ethan. I don't have Tyrone until next hour. Okay, no problem, fine. All right, so x equals negative 2. All right, questions about that process so far? So we're almost done. We know what the x of our coordinate is. Do we know what the y is? No, we do not know what the y is. How can I figure it out? Plug in that x equals negative 2 into either original equation. So it doesn't matter which equation, top or bottom. All right, I heard top first. So that one was, what was it? 3x plus y? Good, so that was one of our original equations. Now for the x, we're gonna plug in what x equals. So it's 3 times negative 2 plus y equals negative 3. And solve for y. So solve for y, I'll let you guys do that. Good. And then here's the work for that in case you didn't get that far. Add 6 to each side. And then negative 3 plus 6 is 3. So y equals 3. All right, and then write your answer in coordinate form. Negative 2, 3 is the solution. Questions, comments? Yes.
Oh, so should next be a positive 2? Since you divided by a negative.
Well, the 10 that was over here was positive. So when you do a positive by a negative, it's a negative. Does that make sense? All right, any other questions? All right, so try example B from start to finish. Use this one as a model, and then we'll see if you get it right. So try example B from start to finish. All right, so the correct final answer you should have had, no matter which equation you picked, would have been 6, -1. So if you got that, then good job. If you didn't, just make sure you're following the steps appropriately. Now, the one that I picked, because you need to pick one of the equations and solve for one of its variables, I just picked the top one. And I chose x to solve for since it's only one step to move the 3y, right? Because we add 3y to each side, so that's what I did. Could have done it a different way if you want. And then I took what x equals, which is 9 plus 3y, and I plugged it in for this x in the other equation. So when I did that, I get 9 plus 3y plus 4y equals 2. So any questions so far? You see how I just plugged it in? All right, and then combine like terms. So 3y plus 4y is 7y. Solve for y, subtract 9 on each side. 2 minus 9 is -7. Divide 7 on each side, and y is -1. All right, and from there, you take whatever value that is and plug it into one of the original equations. It does not matter which one. Again, I just picked the top one, but you could have picked the other one. So I plug it in for the y spot. So this is what it looks like plugged in. And solve for x. So -3 times -1 is +3. Subtract 3 on each side to get the x alone, and x equals 6. All right, so questions. Again, there's other ways you could have gone about it. So if there's not any questions, we'll move on to the next example. All right, and then if you were like copying from it, it is on Schoology, so you can copy it from there. All right, so now we're gonna look at those special circumstances. That's what we're on next. So that's what it looks like when the solution is one solution. All right, you get a coordinate. So don't just say it's one solution, you need to tell me what that solution is. But there's other types of solutions you can get. What are those types? Infinitely many and no solution. So since we're not graphing these, you have to know what it looks like algebraically. So we're just go through the process like normal. We're just gonna pick one of these equations and solve for the variable. So which one do you want to pick? Okay, I'll pick the top one. Again, it doesn't really matter. That one looks like it'd be easier. And do you want to solve for x or do you want to solve for y? So we'll solve for y. Again, it doesn't matter which one you isolate. If I want to get the y by itself, then this is what I have. -x plus 4, or 4 minus x. So now that you isolated the y, you take what it equals and plug it into the other equation for y, since that's what y equals. So I have -x minus y, which is now -x plus 4 equal to 6. So everyone with me so far. Get one of the variables by itself, take what it equals, and we're substituting it back into the other equation. Now we have to solve for x. So go through your steps like normal. First step is always to distribute if necessary. Do I need to distribute? Yes. What number is out here? A -1, even though the 1 isn't written. That negative means -1. So distribute by multiplying each by -1. What's -1 times -x? Positive x. What's -1 times 4? Good, and then bring everything else down. All right, bring down the negative x. All right, bring down the equal 6. And then keep going. Highlight terms. What's negative x plus x? 0. So that canceled out. I end up with negative 4 equal to 6. So what, is that a true statement? Does negative 4 equal 6? No. No, it is false. That does not equal 6. So the resulting equation is false. So the system has no solution. All right. And I think we covered this before, but here it is again. All right. If you get something weird that's not true, no solution. Questions? All right. So then let's look at the other one. So solve one of the equations for one of its variables. Which one do you think would be easier? Good, I would agree. The top one does look easier. Do you want to get the x by itself or the y by itself? Okay, you guys say y. Personally, I would get the x by itself, and then it's just one step. But you guys want to get the y by itself, so let's do that. How do you get rid of x? Subtract x on each side. I get negative 3y equals negative x plus 6. And how do you get the y by itself? Divide. Good. And then we get y equals 1/3 x, and 6 divided by negative 3 is -2. If you guys decided to isolate the x, all we would have had to do was add 3y to each side. All right, so you'll get better at it as we go. But we isolated y. So we're going to take what y equals, which is this, and plug it in for y in the other equation. So right here, I meant to point out. So I have 4x minus 12, and then plug in what y equals, which is 1/3 x minus 2, equal to 24. Questions so far? All right, so then distribute that -12. What's -12 times 1/3? Good. -4x. And -12 times -2, a +24. And then bring everything else down. So equals 24, and then that 4x that was over here. All right, now combine like term. What's 4x minus 4x? 0. So again, x canceled out. All that we're left with is 24 equal to 24. Now, is that true? Yes. Yes. So what do you think our answer is for solution? Infinite. And there is an error on the annotated notes in Schoology for this, because it said that these lines are parallel, but they're not. So to fix it on your note sheet, put these lines are the same. So the system has infinite solutions. But really, it's because this is true. Sorry, that's not infinite. So questions? All right, tomorrow we'll start class with this your turn. As FYI, so that's where we'll end the lesson today.